Hey guys, today we are going to solve this problem, Robert Hood and Mrs. Hood. So this is problem D of Codeforces round 974 div 3. Let's read the problem first. Robin's brother and mother are visiting and Robin gets to choose the start day for each visitor. All days are numbered from 1 to n. Visitors who stay for D continuous days, all of those D days must be between 1 and n, inclusive, both. Robin has a total of k risky jobs and the ith job takes place between days Li and Ri, both inclusive. And if a job takes place on any of the D days, the visit overlaps with this job. The length of the overlap is unimportant. And Robin wants his brother's visit to overlap with the maximum number of distinct jobs and his mother's the minimum. So we have to find out the suitable start days of visits for Robin's brother and mother. And if there are multiple answers, we have to choose the earliest one. Okay, so let me just explain you this problem by this test case, by the help of this test case. Okay, 92479481323. Okay, so I have 924 and I have 794813 and 23. Okay, so this is basically n, the number of days. This is d, the number of days they are going to stay with Robin, his brother and mother, and k is basically the number of jobs that we have. Here we have 4 jobs. So let me just number the days: 1 2 3 4 5 6 7 8 and 9. And let me show the duration of any job by this red color. So we have 7 and 9, one job starting at 7th day and ending at the 9th day. Then we have a job starting at the 4th day and ending at the 8th day. Then we have a job starting at the 1st day and ending at the 3rd day. And then we have a job starting at the 2nd day and ending at 3rd day. Okay, now if I have to say that what do we have to do? We have to find out the day when Robin's brother should visit, so that Robin has most number of distinct jobs to do in those D days. Similarly, for mother, we have to find out that particular day on which if she visits Robin, then after D days of that particular day, Robin has minimum number of distinct jobs to do. So how many days are they going to stay with Robin? 2 days, right? So why not I should create just a window of 2 days, and I'll just slide through the array through these days, and I'll check how many distinct jobs do I have, right? Let's do this. So for 2 days, that is 1 and 2, I have 2 distinct jobs, right? So I'll write here 2. Then let's move further. So I am at 2 and 3. Okay, let me just make it a complete square so that we can do it very easily, right? Okay, so let me just make it here like this. Okay, now it's fine. Let's move. So for the 2nd and 3rd day, we have 2 distinct jobs. So I can write here 2, right? We have 1 and 2 distinct jobs. Fine, let's move to the next 2 days, that is 3 and 4. So for 3 and 4, I have 3 distinct jobs, right? 1, 2 and 3. So for this, I have 3 distinct jobs for the 3rd and the 4th day. And for the 5th and the 4th and the 5th day, I have just 1 distinct job. So I can write here 1. If I move further, 5 and 6, again I have just 1 distinct job, so 1. And then let's move to the 6th and the 7th day. Now I have 2 distinct jobs, 1 and 2, right? So that's 1 and 2. Fine, let's move further. 7 and 8, again I have 2 distinct jobs, so I'll write here a 2. Then we'll move further. For the 8th day, I have 2 distinct jobs again, so I'll write here 2. Now if we move further, what will happen? We will have just if we move further, we'll have just 1 day, but the visit has to be of not at least, but yeah, exactly 8 days, D days. So obviously we cannot take 9, right, as our answer. So that's it. Okay, so now we need to develop some kind of algorithm that can give us these numbers. What are these numbers? These numbers are basically the number of distinct jobs that Robin will have if the visit is made on this particular day, on these particular days. Then these will be the number of distinct jobs that Robin will have to do. And for brother, we have to maximize this. So what is the maximum number in this? That is 3. And what is the first occurrence of 3? This, right? So that simply means that the brother should visit at this day. And for mother, what do we have to do? We have to minimize it. So what is the minimum number here? That's 1. And what is the first occurrence here, right? So this is mother. So the brother should visit at the 3rd day and the mother should visit at the 4th day. This is the correct answer for this particular test case. Now we need to find out how to find out this. What is the algorithm? What should be the algorithm for this particular question, right? Okay, so let's see how we can develop an algorithm for this. So one thing I'm sure of is that I need to do some kind of sliding window in this problem, because the visit is obviously going to be of D days. So I can just create a window of size D and I can traverse through this through these days, and I can just find out the maximum and the minimum number of distinct jobs that I have to do for a particular window. And for brother, I'll maximize those distinct jobs, and for mother, I'll minimize the number of distinct jobs, right? That is the algorithm that we are going to develop. Okay, so let me just give you let me just show you an observation in this array. On the first day, let's suppose that I am saying that, is there a job starting on this day and is there a job ending on this day? Let's suppose I am asking these two questions for each particular day. So is there a job starting for the first day? Yes. Is there a job ending on this day? No. Is there a job starting on the second day? No. This job was already started at the first day. It is not starting at the second day. So no job is starting at the second day. But this job is starting at the second day, right? So I can say yes, there is a job starting at the second day, and obviously there is no job ending at the second day, so I'll say no. In the third day, is there a job ending? Yes, there is a job ending. So, and how many jobs are ending at the third day? 2 jobs are ending, so I'll do a double tick. And is there any job starting at the third day? No, there is no job starting at the third day. Similarly, for the fourth index, is there a job starting at the fourth day? Yes, there is a job. Is there a job ending at the fourth day? No. Similarly, I can fill all these indices. So no job is starting at the 5th day, no job is starting at the 6th day, no job is ending as well. For the 7th day, there is a job starting and no ending. At the 8th day, there is a job ending, no job starting. For the 9th day, no job starting, 1 job ending, right? This is it. So if I can maintain this kind of record in somewhere in any data structure, then I can just slide through this window or slide through this data structure, and I can calculate the number of distinct jobs that I can have in this particular window, right? This is the intuition behind solving this problem. Let's see how can we do that. So what I can do is, basically I can create a vector. Okay, I'll create a vector of size n+1. So I have 9 days, so I'll create a vector of size 10. So what will be the indices of this vector? The indices will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, this is it. So my 0th day is nothing, right? It has no meaning. So I'll start from the first day and I'll create a vector of pairs. So basically this will be the first element of the pair and this will be the second element of the pair. So I'm creating a vector of pairs. Okay, very good. I'm creating a vector of pairs and the index of the vector is telling me the ith day. Okay. Let me just construct the vector. Okay. Yeah, that's it. That's my vector, right? Okay. Obviously, 0th day, there is nothing to do. Now what I'll do is, at the first index of each pair, I'll store a counter that will tell me if there is a job starting at this day or not. Similarly, the second element of the pair in the vector will tell me if there is a job ending at this particular day or not. Okay. So initially all these values will be 0. All these values will be 0. Okay, I'll just store all these values to be 0. Fine. Now let's suppose I'm taking the example of this job 7 and 9. This job is starting at the 7th day, so I'll go to the 7th index and I'll increase the counter by 1. And which counter will I increase? Like what value will I increase? The first one, because the first element of the pair is storing if there is a job starting or not. This index is telling me if there is a job starting or not, and the second element is telling me if there is a job ending or not, on that particular day. And when is the job ending? 9th day. So I'll go to the 9th index, and at the second element of the pair I'll store a 1. Similarly for 4 8 I'll do go to 4, increase by 1 the first, and then go to 8 and increase the second by 1. I'll go to 1 3, go to first, increase it by 1 the first, and go to 3 and increase the second by 1. And then I'll go to 2 3, go to 2, increase the counter by 1, and it is ending on the 3rd day, so go to the index 3. There is already a 1, I'll add 1 to it, it becomes 2. Fine. This becomes the record of my jobs starting and ending. Okay, good. Now what I need to do, I need to just slide through this through this vector, and I'll count the number of distinct jobs that I have for a particular window. What should be the size of window here? Obviously the size of the window should be 2, right? So what I'll do is I'll keep 2 pointers, left and right, and initially both of these pointers will be at the first index. Okay, and I'll increase the right, I'll move the right to the right, and once the window size becomes D, I'll count the number of distinct jobs. Like my counter will have the count of the number of distinct jobs in that particular window. Okay, so what will I do? I'll go to the right index, and my right index will say that if there is a job starting at the next day, then increase the job count by 1. And when I'm moving to the left, then I'll say that if there was a job ending at that particular day, then decrease my job count by 1. What am I saying? You might not have understood it, but after this dry run, you should be able to learn. You should be able to understand this. So that is basically saying that my right will always check the first element of the pair, and my left will always check the second element of the pair. So initially my window size is 0, so I'll move my right ahead. My window size is 1 initially, right? This is my window size and this is 1. Okay, so I'll move my right pointer ahead. So let's see what happens if I move my right pointer ahead. So my right pointer comes here, and okay, I think I'll have to erase it, and my right pointer comes here. Okay, fine. And now my window size becomes of 2 size. Okay, so what will I do? See, I'll maintain a variable of job count. It was initially 0, and my right was initially here, right? What was the count of the first element of the first pair? It was 1, so increase the count by 1. Then it got to the second index, and what was the element at the first of the pair second? It was again 1, so add 1 to it. So I have 2. So for 1 and 2 I have 2 distinct jobs, and that is what I have here, right? 2 distinct jobs. Okay, fine. Now the window size is obviously 2, so I'll have to move both the left and the right pointers ahead. So let me just move both these pointers ahead, right? So I'll just move both these pointers ahead, left and right, both of them. I'll move it ahead. Okay, so there is some issue. Why are not they moving? Okay, I think. Okay, so now these pointers were initially here. Okay, fine. Now what I'll do is I'll move my right ahead, right? What I'll do is I'll move my right ahead. The right will check, is there a job starting on this day? No. So plus 0 becomes 2. Now when I move my left ahead, it will check my second. Was there a job ending at the first day? No, there was no job ending at the first day. So minus 0. So the count stays 2. Okay, it does not change and it stays 2. So now my window has come here, and for the second and the third day I have two distinct jobs, and that is what I have. That is true. Fine. Now my right will again move ahead and it will check the first. Is there a job? Yes. So plus 1. So I have 3. Now my left will move here. It will check the second. Was there a job ending? No, there was no job ending. So minus 0. So the counter becomes 3. And both of these pointers move, right? So I'll just move them. I'll move these pointers ahead. So for the third and the fourth day, I have 3 distinct jobs, and that is what I have. 1, 2, and 3 distinct jobs. Fine. That simply means that my algorithm is working fine, right? At least for these days. Okay. Let's be more confident by doing more dry runs. Okay. So for third and fourth day, I have 3 distinct jobs. Fine. Again, right moves ahead. Is there a new job? No. So plus 0. Okay, I'll just use the same color. So plus 0 stays 3. Left will move ahead. Now here is a 2. So you'll do a minus 2. So your job count becomes 1. Right? Your job count becomes 1. And the window comes here. So for the fourth and the fifth day, you have just 1 distinct job. Yes, and that is what my job count is doing. Very good. I'll move again further ahead. So my job count was, okay, I'm sorry, it's here. Okay, now it will move ahead. Okay, so now it was here. It will move ahead here. Was there a new job? No. So my plus 0. And was there a job ending at the fourth day? No. So minus 0. So it will stay 1 here as well. Fine. Now when I move again further, there is a 1 here. So plus 1. So this becomes 2. Is there a job ending on the fifth day? No. So minus 0. So 2. So now my window comes here. 6 and 7. So 6 and 7 I have 2 distinct jobs. Yes, that's true. For 6 and 7 I have 2 distinct jobs. One this and the other one this. Again, do I have a job here? No, I don't have. So 2 plus 0. And also I should not write here equal to. I should write here, this. I should write here this. Okay, right. You should understand this, right? This is not equality. This is just, progressing of job count. Yeah. So no new job is adding. And is there a job ending on the 6th day? No. So minus 0. So this again stays 2. So for the 7th and the 8th day, again I have 2 distinct jobs, and that is again true. And then again I'll move further, and again they will be 0, and I'll have again 2 distinct jobs for 8 and 9 as well, right? So these numbers that we were trying to get, the number of distinct jobs that we'll have for a particular D window on the ith day, these numbers we have got by using this vector of pairs, right? So this is the core logic of my code. What I'm doing is I'm maintaining a vector of pairs, and at the ith index I'm saying that I is the day number, and the first is storing the count of the jobs starting at a particular index, and the second is storing the number of jobs ending at that particular index. And then I can just slide a window of size t through this vector, and I can simply count the number of distinct jobs that I have for those particular D days, and then I can maximize and minimize the answers for brother and mother respectively, right? So let me just show the code for this. This is the code. So created a vector of pairs, initially stored the values 0, stored the k, l and r values and stored the starting of the job in the first element of the pair and stored the ending of a particular job in the second element of the pair. Then I put two pointers left and right initially at day 1, and I'll slide the window through the vector once the right has not reached the end of the vector size or the end days. And if my window is not of size d, it is lesser than that, then I'll just add the number of jobs starting at the right index and I'll move the right pointer ahead. If at a particular point I'm getting the window size to be d, I'll check the total number of jobs in that particular window, and I'll minimize and maximize it for mother and for brother and mother. Okay, maximize it for brother and minimize it for mother. So this is it. This part is very simple. And then I'll move my window ahead, and if there is a job or if there are jobs ending at the left index, I'll subtract it from my job counter, and if there are new jobs coming at the right index, I'll add it to my job counter. That's it. That's the simple implementation of this logic, right? So the code is very simple and you can just understand it very well. And still, if you haven't understood this problem or you want more clarity, then I'll strongly recommend you to do a dry run on few test cases and you should be familiar with the logic, right? Yeah, so that's it. And if I talk about the time complexity is somewhere O of n, because it's simply linear time O of n, and the sliding window is again O of n, and accessing the elements of pairs of vector, it's again O of 1. So it's completely O of n linear time logic, right? So yeah, that's it. I hope you have understood this problem, and yeah, see you in the next video. Bye.